Smartwatches have become popular devices due to their constant flow of information and connections, as well as their always accessible nature. Because of this, the use of smartwatches is often quick, used while on the go, and/or while encumbered. However, while smartwatches have become a common and useful device throughout our day-to-day lives, the interactions they utilize are often limited and affected by the size of the screen and their scenario of use. Due to these scenarios, users must often be aware of their core task, promoting the need for rapid and at times eyes-free interaction. Smartwatch bezels as a means of interaction provides a unique approach that can allow for fast, eyes-free interaction and command invocation. Previous work has explored bezel-to-bezel and bezel-initiated swipes with success, however only in static conditions. We also note that bezel-to-bezel, or B2B, offers users with the ability for an increased set of interactions that bezel-initiated swipes cannot provide. Thus, in this work, we explore B2B gestures on a round smartwatch while eyes-free in static, mobile, and mobile while encumbered conditions. We utilize 3 segment conditions in this work, using 4, 6, and 8 segments of the total circumference of the bezel. We conducted 2 user studies exploring B2B and concluded by utilizing machine learning and calculated features to enhance the interactions captured. In the first study, we explored B2B gestures while seated and eyes-free. The B2B gestures were performed correctly by touching down in a start segment and swiping through the center to an end segment before lifting up. This study provided a baseline from which to better understand B2B interactions on a circular smartwatch. We analyzed accuracy, time, and the touch points of participants' interactions. Our results showed overall accuracies of 97, 88, and 74% for the 4, 6, and 8 segment conditions respectively. Further, we note that the start of the interaction is more consistent, with users often accurately starting in the start bezel segment. Interactions discretely changed direction in the center of the watch towards the end bezel segment, which was often less accurate. In our second study, we aim to understand the effect that mobility and encumbrance has on the B2B interaction. To do this, we explored B2B while walking at a speed of 2.6 kilometers per hour, with participants' hands either free or both hands encumbered with bags weighing 1.6 kilograms. Results provided insight into the interaction during natural use case scenarios. The results of this study showed that accuracies significantly decreased for certain conditions. For the 4, 6, and 8 segment conditions respectively, the overall accuracies were 90, 82, and 67% in the walking condition, and 89, 74, and 57% in the walking while encumbered condition. Further, when comparing touch points, offsets, and the time for their interactions, we note that the B2B gestures remain relatively similar to the first study. For specific results, please see the paper. In the third part of our work, we improved on the results of the previous studies through machine learning using captured and calculated features. With the ability to utilize B2B gestures to perform rapid commands on smartwatches while on the go, we lastly propose applications and future work. We propose utilizing marking menu responses, shortcuts, or menuing for quick invocation and navigation. We present understanding and adapting bezel-to-bezel interactions for circular smartwatches in mobile and encumbered scenarios. This work provides knowledge of the benefit of B2B gestures for effective and eyes-free interaction that can be performed in natural usage scenarios on circular smartwatches. Thank you.